Hi folks, a few days ago I made a video segment which dealt with modal analysis of a fixed frame, and it's it looked very similar to what I'm going to show you, but uh, with some differences which are significant. First of all, this problem is taken from the work of this YouTuber down here, and this entire thing is done in the ABAQUS CAE. So I'm referring to his work, and the problem that I did was very similar to what you see here. The difference is that the vertical column on the right side, first of all, it has the same length as the one on the left, and the bottom of it was actually fixed. The bottom of the vertical member on the right was fixed, clamped. Now, the dimensions were different and material properties obviously were different, and the cross section. But you might say, well, if I know that other video, then this is pretty much the same. It's just that different boundary condition, etc. The answer is correct. You're correct. However, there I created my geometry as a sketch, a two-dimensional sketch, and then I had to join it so that the entire structure, which is just two vertical columns and a horizontal beam, were meshed at the same time. And therefore, there were no duplicate nodes at the junction between a column and the beam, the columns and the beam, okay? Because they were joined. Not everybody does this, so what I'm going to do is repeat the same problem. Obviously, the bottom of the column on the right side is different as far as the connection is as far as the strain is concerned, but I'm not going to join these things. I'm going to create it as a wireframe, three lines, a vertical line, a horizontal line, and a vertical line, and these are in space. And when I try to mesh these things, you have to be careful, because if you're not, then at the junction between the beam and the column, you're gonna have duplicate nodes. We'll see that. Incidentally, I will assume that the entire top floor, or uh, the the beam is rigid, and it has a mass of 500 kilograms. Also, I don't want these columns to participate as far as the natural frequency is concerned. Therefore, I artificially reduce the density of the material in these columns by a factor of 10,000. Okay? Now, uh, these are the results that were obtained by that YouTuber, and these are the ones that will be obtained in the 3D Experience platform, and you see that they're very close, and that should not surprise you, because the solver in the 3D Experience is actually the ABAQUS program. Now, uh, the one thing you have to keep in mind, because the beam, the horizontal beam, is going to be rigid, and there's going to be a lumped mass there, they must be referring both the rigid connection and the point inertia, or the lumped mass, must be placed at the same location, which is in the CAE program they refer to it as a reference point. And I also need an orientation point down here, because the cross section is not the circle is not circular or tubular, and therefore you have to specify the proper orientation. And I did that, and you will see that when I mesh it, as long as if I don't capture the duplicate nodes, then what happens is that there's going to be two nodes at the same location, one from the left, one from the right. So let me go back here. If you capture node and mesh on constraints, then there will be no duplicate nodes here. Otherwise, they will be. And we're going to do that. I'm going to demonstrate that later. Okay. So let me go ahead to the 3D Experience interface. I'm going to create 3 points. Uh, First one is down here on the left side, the bottom of the column on the left side. So let's go ahead and create one down there, 0, 0, 0. Then we're going to want to create a node way up there, which is, I believe the length of the column was 6 meters. So that's going to be 6,000 millimeters up. Okay. Then it's going to be the right side of the beam. On the right side of the beam. So the only difference is that the y coordinate is also 5,000. And finally, we're going to go down to capture the bottom of the right column. So that is going to go to, as far as the height goes to 2,000 millimeters. Okay. And finally, I'm going to create an orientation point. Its location is at least for our problem is not that critical. In other words, I can go to in the x direction. I can go maybe 1,000, so I can see it. Okay, good. So that's the orientation point, and then I cancel. So I've got 4 points. Now I'm going to draw lines from here to here. That's the first line. This is going to be the beam, the horizontal beam. And this is going to be the vertical column on the right side. The column on the right side. And okay, and then we cancel. All right. Notice that if I join these three in the generative shape design and mesh it, there won't be a problem. There won't be any duplicate nodes. However, I'm not going to join that. So let's go ahead and actually define some material properties. So we go to tools, and here's a create material, and today is February 3rd, 2024, and we call it steel. Okay, say okay. Actually, this is not steel that we're using. The Young's modulus is the same, but the density of it is not. Although we're not going to use the density anyways, but I should not have called it steel. But that's fine. It's that material that I showed you in the slide. So apply it to that green check mark, and now we go and input our values. So it's a structural problem. We need to specify the density here. And remember, this is the reduced density by a factor of 10,000, so 0.24, which is pretty much nothing. And then we're going to go to ABAQUS multiphysics, mechanical, elasticity, elastic, 3D GPA, and Poisson ratio 0.3. 0.2 according to the description of the problem. Let's do a quick save here. All right. So now we're going to go to the mesh generator in a sense, which is the application called structural model creation. It's an empty FEM. All right. And I'm going to go to the mesher, beam mesher, and the support, and we have to do this thing 3 times because these are not joined. If they were joined, I would select one of them, the whole thing is going to get meshed. But I'll have to do this 3 times, but that's not really the issue here. See that there's a box here which says capture nodes and mesh edges on constraint. I will uncheck that because I want to show you what happens if you do not take that into consideration. And what I'm showing you is actually this slide. Okay. So as far as the size is concerned, 200 millimeter, linear, element order linear. Okay, very good. And we're going to say mesh. Oh, I have to select the support, which is this left edge. Say mesh. Notice that the elements are created here, and I have to repeat this thing 3 times. One more time. So here's the first one that I did. Another one is going to be right there. Again, this is not checked, so mesh. Okay. And last one on the right, mesh, and okay. Good. So we have created the mesh. Let's not worry about the cross sections. I want to see where the nodes are. Okay, so first of all, these points that you see here are totally in our way, so I'm going to hide them all. This last one is going to be used later on for orientation, so I'll just leave it there. I'm going to hide these. Okay, good. Now, first of all, have we meshed it? If you look at the right-click mesh visualization, I don't want to see the part, so I'm going to uncheck that. But you can see the elements here, and in fact, if you go to display and you shrink the element, one-dimensional element, you can see them better. You can see that, okay? This is when they're not shrunk, so that's fine. So they are meshed. Now the question is, what are the nodes at these corner points, okay? So if you go to try to do this, it says, well, first of all, let me update the whole meshing function that I did. And then if you go here, it says numbering visualization, you click on it, and because I updated, it didn't complain. Otherwise, it will come back and say updated or something like this. So let's see now. If I go and select this element, for example, let me zoom in. Let me zoom in. Element and show me display the node number. So I select this element, and I want to be able to see the nodes, entity, both nodes and elements. It's kind of hard to see the node numbers based on background color. So let me change this thing to blue. There. Okay, so let me select this element. It says this is element 31. The left node of it is 32 and the right node is 34. Now notice that it says node number 2 right there. But if I select this, it says node number 32. So notice that there are duplicate nodes here, and same thing on this side. Now when you join things and do this, it doesn't matter. They're going to be identical. Node on this side is 30. What is that? Turn this thing around. On this side it is 33, and on this side it is 58. Okay, so the question is, how do you fix this thing? No problem. I'll leave this background color the way it is. So I go to my meshing. I go back to my meshing, this, and I'm going to say capture node and mesh edges on constraints. So say okay. So within 1 millimeter of each other, they're going to be captured and basically merged. So mesh, no problem, done. Let's do the other one. Same thing. Mesh, say okay. And last one, check it, mesh, and okay. And let's update everything. Okay, now let's go and check the node numbers. So we go here, mesh visualization. I had to update, and I did do that. Now we'll select the node and put the cursor here. It says node number 31. And when you go from the other element, node number 31. So there is no discontinuity here as far as node numbers go. Now, in the event that you didn't do that, then you have to come back and tie these nodes together, which is not going to be the present tutorial. Okay, tutorial 3 is going to be repeating exactly the same problem, and I'm going to leave that thing as different nodes, and we're going to tie them together. So okay, good. So this is all done. Now we're going to do the cross section. Okay, so see for a second. Let me see the mesh. I don't want to see the mesh anymore. or I want to see my part right there. Okay, so we go to properties. First of all, do the profiles. Beam profile. The first one, let's say, is going to be the the first one is going to be the uh, column on the left. So I'm going to call this thing column left column. Okay, and it's going to be rectangular. In fact, it's going to be square, but it's okay. So based on the drawing, it's a slide, is 150 millimeter by 150 millimeters. Okay, then we do another profile. See, the profiles are being recorded here. We do another beam profile. I'll call it the right column. Right column, and it's going to be once again rectangular. And based on the slide, it is 225 and 225 millimeter. Okay, and the last one is going to be the beam, the horizontal beam, horizontal. How about call it beam or top beam? Let me call it top beam. Top beam, rectangular, and the dimensions are 100 by 100. Okay, good. We have created the profiles here. Update that. Okay, now we're going to create the beam section. So beam section 1, I'll call it the left column, left column. And left column is made of the support is right here, and the profile is the left column that I created. And for orientation geometry, I'll select this point. Okay, and then we say okay. All right. Notice that the properties are being created one by one. Let's do another one. Let's do the right column. Call it what do I call it? Right column. And the profile is or the profile. Oops. It's this one, right? Oh, that's the right column. That is correct. Line 3. And the beam profile is the right column profile. And once again, orientation point right there. We say okay. And finally, the top beam. So we select this. I'm going to call this thing top beam in compliance with what I've already done. Okay, and the profile is going to be top beam. And for orientation point, I'm going to select the same. You say okay. Good. Now, if you want to see the cross sections here, first of all, let me update. You can go to display under display. Okay, now if you want to see the cross section, you select the display under the display preferences. You choose instead of none, you say show me the solid, and it will show you what the cross section looks like. Okay, so that's good. I don't need to see that anymore. I'm gonna say don't show me it and close that. All right, so now the rest of the problem is once you did this thing, then you're going to go to the structural scenario creation. Okay, it's a finite element model that we created. All right, so on the procedure, we choose the frequency step. Let's use 10 frequencies. Default is 10. And now we're gonna apply the boundary conditions here. Boundary conditions at the very bottom of this thing. It's a pin. It's a clamp condition. So all 6 degrees of freedom are fixed. You could have used clamp if you wanted to. And then, incidentally, if this is too big, once again, display, preferences, reduce symbol size. Okay. I made it bigger because I wanted to see the cross section before, but that's okay now. Now this one is pin, so we go boundary condition. Same thing. This point, make sure you put these restraints not on the points, and that is why I hit those points. Okay, you put it on the vertices. So this is a pin. So 1, 2, 3. All right, now we want to declare this thing as rigid, etc., which I completely forgot to do. So we're going to go back to meshing. I completely forgot about that. Okay, let's go there. So under the connections, here's a rigid connection. You select this top beam, and for the support, I have to create a point here, which is going to be essentially my reference point. So you can say right click, remove all, or right click, create a support. And what I'm going to do is I'm going to select this line. Okay. And the way I'm going to do that is on this curve, halfway between. So let me see now. On a curve, on this curve, okay, exactly halfway. So ratio of curve length, and I put down 0.5 here. So a point is going to be created right there at the halfway point. You can see that. Now that's going to be probably point number 6 in the where is that? 0.5 or point number 6 right there, because 0.5 was the orientation point. And so this is going to be a rigid member. You say okay, and now we go to abstraction, point inertia, and the location is, if we can do it from here, it's fine, but it's going to be essentially 0.6. That's what it is, 0.6, and the value of it is 500. This is the step that I forgot, and I went through my structural scenario creation prematurely, but I can go back. Now, by the way, let's check something here. If I double click, let me first display the cross section here. Display under preferences, not shrink. On the preferences, say, okay, show me the cross section. There we are. Close it, because I want to show you something. So this thing that you see here is essentially this slide, but I want to check, make sure that these are referring to the same point number 6. Okay, so let's go here, double click on this rigid connection that you did right here. Double click on it. You should say refer to oh, this should be 6. So cancel that. Let me try the other one. Where is this abstraction? That one is okay, but that connection one, that rigid connection one, it should have said 0.6. So can I select 0.6 from here? Yeah, now it's okay. Now it's fine. So these two both must refer to the same, both the rigid connection and the inertial mass, point inertia must refer to the same support to support, basically reference reference point, as it's put in the ABAQUS CAE program. In my case, it's 0.6. Okay, not 0.10. This was another run. Okay, good. So now we're going to go back to our scenario creation that we just started. Okay, we put the restraints here, and that's pretty much it. There's nothing else we need to do. We have the restraints. We created the inertia, mass inertia. We may declare this thing as rigid. They both referring to the same reference point. And let's go ahead and run it. This is a quick model check. This is a simulation check. And remember, in the next video 3, I will repeat this exact same problem, except that I will not ask for capturing nodes that are within vicinity of each other within 1 millimeter. I will leave them a separate node, then I have to go back and fix it, as you'll see later on. One of the reasons I do all three of them is because you really don't know how the problem is going to be attacked by yourself or the user. So depending on what pathway you follow, you have to make the appropriate adjustments. I think this is good. And now we're going to run it and we can look at the frequencies. Once again, remember in tutorial 1, I joined the 3 lines, so there were no issue. In tutorial 2, which is right now, I did not join, but I made sure that the duplicate nodes are captured within a certain tolerance. And in video 3, I'm going to leave them as separate nodes, distinct nodes at the junction point, and then handle it differently, perhaps by tying them together as additional constraints. All right, so this is done, extracting the results, and right here, what you see there is exactly what I have in there. All right, folks, good luck.